I built a neuron from scratch. You're probably like, what's a neuron? What does building it from scratch even mean? Aren't neurons the things in your brain? Slow down. They're not as complicated as they seem. I know a lot of YouTubers make it seem like you need a PhD, 3 monitors, a lab coat, a super crazy computer to understand it, but you don't. Maybe I'm saying this because I understand it now, but by the end of this video, you should understand it too. Why am I pointing? And if you don't, that just means I don't understand. So really, you have nothing to lose. Watch the video. You're wondering how a 17-year-old like me built a neural network from scratch without PyTorch, without NumPy, or all the giant libraries everybody uses. Is it because I don't know how to use those libraries? Of course not. Why would you even suggest something like that? What's wrong with you? Get that person out, him in the back, get him out. Why do you even suggest me learning any libraries? Get him out. Let's come back. I remember it like it was yesterday. Right after I learned Python, I thought to myself, what if my real first project was a neural network that learned XOR? The programming equivalent of saying, yeah, I just passed my biology class with a B+. Now I'm gonna go develop the cure for cancer. Okay, maybe that's a stretch. Maybe it's not that far. It's not that far. So first, let's answer a simple question. Where's my marker? My marker fucking. I was gonna write on the board, but my marker sucks. Don't even worry about what this is. A neural network is exactly what it sounds like. A network of neurons. And a neuron is simpler than people make it sound. A neuron takes an input, multiplies it by its weights, then adds them back together, then adds a bias, and then spits out a number. That's it. That's the whole entire thing. If you strip away all the scary math symbols and the squiggly lines and the e's, it just comes down to the math you learned in high school. Just simple linear equations. You can think of it as y equals mx plus b. To act like the slope and the bias acts like the intercept. I don't want that. A neuron is basically like drawing a line. That's why we call it a linear neuron. Is that redundant? Because all it can do is draw a straight line. So when a neuron learns something, all it's doing is basically adjusting its weights and bias so that line goes through a certain point. That's it. No magic, no consciousness, just a really stubborn line trying to hit a dot. Like, just imagine if when you learned how to walk, you flailed your limbs everywhere until like you moved and then you were like, oh, that's good. Let me keep flailing in that direction. That's it. Now, what I just said is just one neuron, and it's basically useless. You can't do anything with just a line. How am I supposed to ask ChatGPT to do my homework? Here's the problem. A single neuron can only do so much. I mean, if you have a simple equation, then you can use a single neuron. But if you have nice complex points like XOR, I didn't put anything in the board, did I? Everything falls apart because XOR isn't complicated. XOR is a logic gate. You know logic gates. You're watching this video. You don't? Oh, okay, so let me explain it. Think of it as a function. It takes in a set of inputs. Let's say it takes in 1 and 0. It takes in 1 and 0, and it'll output a certain number. I mean, not a certain number, but it'll output either 1 or 0. So if it takes in a number like 1 and 0, then it'll output 1. If it takes in 0 and 1, then it'll output 1. But if it takes in 1 and 1, it'll output 0. And if it takes in 0 and 0, it'll output 0. You basically get patterns. You have a brain. You can see the pattern, right? Oh my god, guys, I got a marker. We're saved. Now, if you're thinking and using your brain, you can see the problem. One single line can't go through all these points. It's impossible. I want you to guess what we're gonna do, huh? Go down in the comments and guess. But this was actually a famous problem. Old scientists and AI engineers of the past struggled with this. They were like, oh my god, how can we make a neural network learn this? How can one line go through all of these points? What the brilliant solution is. You can't even guess it. None of y'all are gonna get it right. They added another neuron. Oh my god. Oh my god. Instead of just one neuron, one stupid neuron, we stack them one on top of another. You take the outputs of neurons and you feed them into other neurons and other neurons. Instead of one line, you have multiple lines going. Okay, they're not going everywhere, but like, you have more versatility with your lines. The system becomes way more versatile. And most people call this stacking of neurons, called a hidden layer. A hidden layer can have a variety of neurons. It can have 2, 3, 4, 5, 6, 7, 8, 9, 10. My recording device decided to explode on me, so we're gonna have terrible audio for the rest of the video. Just a few neurons working together can solve XOR. But no, they can't. Stacking linear neurons on top of each other just makes one bigger linear neuron. That's why we need the activation function. Why am I? There's nothing on the board. There's actually stuff. Activation functions come in many flavors. There's sigmoid, relu, leaky relu. Those are the only ones I know. Which stands for rectified linear unit. Rectified linear unit. It's complicated, but it's not. If the number comes into the neuron and it's negative, then relu is like, here's a 0. But if it's greater than 0, then relu gives you that number back. One tiny rule like that changes everything, because now it allows neurons to decide when to be active and when to just stay quiet. which lets neurons shape data in ways that straight lines could never. So now we have all the pieces. Input, hidden layer, you understand what an activation function is. So how do they actually learn? The answer is actually very surprising. It's brute force. You start with random weights, completely random. So at the beginning, your neuron's basically just throwing stuff at the wall to see what sticks. Then you show it the correct answer, and it just cripples in depression. And this is called the error. The error comes from taking the terrible, horrendous guess that your neuron makes and comparing it to the value you actually want. Then your neuron looks at this and goes into a phase called backpropagation, which is basically like imagining a huge assembly line. And your job is to make the star big. And so you take the star, you make it big, you pass it to the next person. And then that person passes it to the output, but then the output doesn't want a big star. So you know what that means. The output will look back and be like, who made this star this big? And then everybody's gonna point at you, and you're gonna have to get reevaluated. So basically, in neural network terms, backpropagation is finding who made the mistake and how big the mistake was, and how much did they contribute, who contributed the most to the mistake. That's what I meant to say. And then there's something called gradients. Gradients is, depending on how much they contributed to the mistake, how much should you change them? Should you A, fire them, B, whip them to, I can't say that. I can't say that in a video, right? I can't say that. So, you're probably wondering, when you first built your neuron, did it work perfectly? No, it did not. It did not work perfectly at all. And all I saw was zeros. My neurons completely died. And relu has this problem called the dying neuron problem, dying neuron problem. And so I just switched to sigmoid. You know, why try to figure stuff out? Why try to be an engineer? But look at it, it's learning. Oh my god, look at it. Oh my god, look at it. Crazy learning. Oh my god, look. It learned XOR. It learned this. It understood this. Hey, like, man, I lost recording equipment in the making of this video. Please like and subscribe, maybe. It's free.